recording. Dear participants, today we have session presenter Dr. Puneet Karat. He is in basically mechanical engineering, completed Bachelor of Engineering from St. John College of Engineering and Management, Palghar, under Mumbai University. Later, he completed his post-graduation from VJTI, Mumbai, M.Tech Production Engineering. He completed his doctorate, PhD, Mechanical Engineering from Institute of Chemical Technology. He has worked in various organizations. Initially, please, others, please mute your mic. He started as a career as a lecturer in St. John College of Engineering and Management. Currently, he is working as a design engineer at Tritalk Equipment Private Limited. He is leading product series, 5 product series he is leading. He is leading a team of, say, 10 plus design engineers. His expertise in the field of, say, SolidWorks, ANSYS, and Zoha projects. He has developed multiple skills related to the design engineering. At the same time, he is using optimization techniques and some of the AI tools for designing the engineering components. So I welcome Dr. Puneet Karat for today's session. And I hand over this session to Puneet Karat to present the topic, that is optimization, AI optimization in the design. Dr. Puneet, you are welcome here.
Thank you so much, sir. Good afternoon, everyone. So I'll just share my screen. Is my screen visible?
Yes, sir, visible, but we have to do presentation mode, sir.
Yes, sir.
Yeah, sure. What is going? Yeah. Now?
Perfect, sir. Thank you.
Yeah. Just a minute. Yeah. So good afternoon, everyone, and welcome to the AICTE ATAL Online 6-Day Faculty Development Program. So I'm going to present on the AI-driven optimization techniques in mechanical design. So first of all, I thanks Zeal Institute for this opportunity, and special thanks to my academic guru, Professor Shivaji Shelar, sir. So he was my HOD in HJCET, and he helped me and guided me in various stages, right from the MTech to the PhD also. So we'll just start. So today's motivation or thoughts to conduct these sessions, that we only need one idea that can change our life, and we all are like a teachers, okay, and we are guiding multiple students like a 60, 120. Even our one idea can change other lives, it will be the great. So in this entire session of 1 hour, whatever this 60 minutes, 80 minutes, if even you get some good idea, insight, or practical takeaway, it will be the great for me actually. So my introduction is already done. So yes, I'm leading a team of around 10 to 12 designers at Tritalk Equipment Private Limited, Pune. So our manufacturing is at Pune and head office is in Thane, and we have various branches across the globe, right from the Middle East, USA, Germany. So I'll just give you the small introduction on my company. No, is that audible, no? Clearly?
Yes, sir. Yes, you
Yeah.
Yes, sir. Yes.
Yeah. Okay. Thank you
Yes,
so
sir.
much. So Tritox provides the solution in control bolting or on-site machinings. It's works for the oil and gas, power, constructions. Nowadays, we are into the wind energy like Adani, Envisions, Suzlon, etc. Even for that bridges like this, you can see that's Pandam or this is a bridge in the south where we provided our tools for the fitment. You can see here the how the tightening is going on. So we have around a 3 decade plus experience in service also, and from the 1.5 decade we are making manufacturing our own tools in-house with in-house R&D. So these are our tools. So right from the hydraulic torque wrenches, hydraulic bolt tensioners, coil cutting machines for the in situ machinings means in refineries like Jamnagars or in Middle East, we need to work without hampering the continuous works. So we are using coil cutting. Coil cutting means without generation of the sparks. So actually it is using the hazardous areas. Then we have the power packs to run these tools. We are developing now the battery torque wrenches, and we have thousands of sockets, thousands types of sockets. All are made in-house. Why I'm introducing this? You can tell your students, and they can get internship also. We have even I had interviewed different students from the MIT because MIT Allen is near to me and had a nice intern. So you can tell your student also. We normally hire interns regularly for their future also, and we also absorb them. So today's agenda will be like what are the traditional mechanical design processes, how AI currently working for generating the CAD from just text. We need to give the prompt and it will automatically generate the CAD model. For that, our prompt must be perfect because according to our input, it will generate the CAD. So then we'll see the AI plus CAD tool integration like a SolidWorks plus Make Agent, and there are several tools are coming now in the market. Those are not free, but yeah, we'll discuss it. Then introduction to AIML. Though AI is a big body, we'll see the machine learning types and how I use my ML in my research project in my PhD. So yeah, as we know, the traditional design process is all started with the requirement of collection requirement. Then we do some hand calculations using the analytical formulas, whether it is a Levy's equation for the gears or power is equal to 2 pi by 60. That is analytical formulas we know from the years. Hello. Hello.
Yes, sir.
Any issue? Somebody told hello. That's why I stopped. Yeah. Okay.
No, sir. Continue, sir.
Then we do the CAD modeling. As we know, in even in third sem, we do 3D modeling, SolidWorks or NX or any other application available at our institute. Then we go for the material selections, FEA validation, which covers the biggest part in design, at which is the time consuming and cost. It also need a cost to the company. Then we go for the prototype testing and we do the iteration until we get success. That is, if you are making a gearbox and your required output is around 1400 Newton meters and you don't get it, you will try it until you get that. So this is the traditional process. So obviously it has some limitations. So I intentionally highlighted with the red marks like it is time consuming. And it is personal experience. It is based on personal. Like if I have 10 years of experience, I can do that things in 10 minutes. But what about the freshers? We need to teach a freshers till he get some idea about it. So and with human mind, we can have the limited combination for that time. So again, there may be the human errors and limitations due to the time constraint. In industry, we normally don't get more time like we have time in our research, like 5 years and all for the one one product, but industry, no, you need to get results in 1 month. So I have a I'll give you my example, like what I've done in my PhD. So from traditional design to parametric optimizations. So you can see the parabolic trough collector. So normally it is made up of the metal structure on which metal strip mirror strips are attached. Hello, can you please mute your mic?
Don't they? Meeting else.
Professor Sai Prasad sir, please mute yourself, sir. Professor Sai Prasad sir, please mute yourself.
Okay, I'll just continue. So whatever the incoming solar radiation coming on the incident on the mirror strip get reflected back and concentrated at the receiver. So whatever flowing through the receiver, like oil or any liquid, get heated, and then we can convert it into any other form of the energy. So it was my project. So as you can see, it is made up of the whole metal structure, and even the metal structure itself for 300 plus kg. And then later, what we found, we can optimize each product, each component. And for this example, I have taken a receiver support. So we searched various literature and found that there can be the three best possible receiver arrangement. So it was A was the earlier one, B was we got from the and our literature survey, and also C from the literature survey. But from the further analysis, we come to know that the B can be the best, as it is at center, though no need two places for the fixtures. So we took this B with a deep study, and then for optimizing that structure, we made some initial sketch with various terminology, like what will be the length, what will be the distance, what is the member size, member thickness, and also search for the market, what kind of members are available in the market. Okay, and this is a basic design for the every component. Like we normally do the CAD, then in FEA, first step is meshing, then we got the results like a deformation analysis, stress analysis, so then FOS, and several depending on your requirement. So it is a basic methodology. Then there are several beam and member available in the market. Like you can have the circular pipe, square pipe, L angle, even there are C channels also. But I have considered around these three basic sizes for my analysis. And we made some 6 combinations. And accordingly, 6 combinations, we got around 812 possible design. Like we have beam outer dimensions 30, 25, 20, because we don't need smaller one also, because it will deflect more, and the larger one will increase the weight. And then there are beam thickness like 1.5 to 2.53 mm. Then there are some assumptions like for if you wanted to do the welding, you can't take a 1 mm, because in normal welding 1 mm sheet is not sustainable. Then square pipe, circular pipe, and various. So we got around 812 design only for one component, and having making that CAD model of 812 models, running the FEA and generating a data itself a tedious job. So it will take more time. So what we do, we went for the parametric analysis. It is a part in our, you can do it in SolidWorks simulations. So we gave the beam thickness right from the 1 to 3 mm, member thickness 1 to 3 mm, and we generated around 25 scenario in one analysis. So instead of 812, I hardly done 30 to 35 analysis. and result in form of the Excel we receive. Then we analyze that result like a data we analyze. Then we do some multi-criteria decision making, and then finally we choose some thickness. And our new design was like that. Like in center, you will get the receiver support. The entire structure is not at change, though you can see earlier design was different. So for the every component, we have done the optimization. Here I am showing just receiver support as an example. So what was the outcome of the analysis? Whether you are using AI, ML, there must be some output. But by parametric optimization, what we get, older design was the 17 kg and newer one was the 6 kg. So almost 67% reduction in mass. Reduction in mass means reduction in cost. Then reduction in the torque, which was the main factor for my project, because reduction in torques is directly proportional to the tracking system. So there directly affects the gear and the motor required for the tracking of the solar collectors. And in overall reduction in the structural mass was around 16%. So it was an achievement. So instead of 812, I have done only 30 to 35 analysis. So from traditional to we can say AI-based kind of approach it is. So it was how the traditional and AI-based approach is all about. Now we will move towards how AI applications are available in the market for the generation of the CAD or 3D model easily with just prompt. There are several like a Zoo, Make Agent, CAD Scribe, Leo AI, and we can integrate it with the SolidWorks, Autodesk Fusion, or others also like a Siemens, NX and all. So here is one example for the text to CAD. There is one application called Zoo. You can download it, and it is available for free for some prompt or some credits only. So I have generated one metal block. Like you can see here, you need to give proper prompt. Like make a metal block of dimension 300 by 200 by 2 mm thickness. All four corners fillets of 20 mm, four corners having four holes of 30 mm dia at a distance. Sorry, even I my spell was wrong. Even he considered it 50 mm central hole of 50 mm. So you can see the four hole at the corner, 2 mm plate central hole. Then I wanted to change the thickness. So I just again I gave prompt like please revise the thickness to 20 mm. Automatically it changed thickness, though it takes us around 2 to 3 minutes. It's all depend on your internet connection. Okay, and how complex is your geometry. So here you can see in the red, the hole is not properly drilled or it is not through all. So what I do, I have given another prompt like require all four corner hole through all. So here you can see I got whatever I want, like a plate with the four holes at the corners and one central hole. This is how you can generate a CAD without having a CAD application, expensive CAD application like a SolidWorks. You can go in a market, you will get it at 5 lakhs for the commercial, and for the institute it is affordable, or they gave a discount but for industry they don't. So this is the first example. Are you enjoying or just boring after lunch? You can give me a feedback, huh?
Yeah, yes, we are enjoying.
Okay. So next, I created spur gear. Like I said, you in my product line, we are working on the battery torque range, and for that, one of the important assemblies, planetary gearbox, where multiple gears are required, and that in that we have changed some profile. So I gave the prompt like create a gear with 17 number of teeth, model 1.25. profile shift positive of 39.39. So profile shift is given for the strengthening the tooth. Okay, it will automatically increase the root dia, OD, etc. And it made the gear within a minutes. Even in next prompt, I gave prompt like I need a exact dimensions of all the parameters. Like a module is already given, teeth are already given. What is the PCD? What is the addendum, dedendum? What is the outside diameter, which is very useful while the manufacturing. Making the CAD is easy, but it must be the part must be manufactured easily. Otherwise, it's create the issue at the manufacturing part point of view. Then root diameter, bore diameter, which was already given. So this is how we can generate a gear. And again, there was one online site available like a CAD scribe. Again, same prompt I gave there, and you can see the different geometry. You can see here how the root was here totally straight, here quite deep. So I imported the step file, and then we check with our existing model. Like we had one gear with the same specification. We had a sketch of it. We merged both, and almost 85 to 90% gear was matching right from the profile. Means we don't actually need the expensive software for it. Though we also need to do for the gears, you can use the Keysoft software, which is also 5 to 8 lakhs for the commercial use according to the package. But from that, we get the exact profile. Initially, in any AI, we need to work little bit hard to generate the data or train the AI model. Even if you are using a chat GPT, using a chat GPT on fresh computer or fresh login is very different from the you are using for the continuous, because it have the history, and according to the history it makes your next report or next output to your prompt. So we'll move next to the CAD plus AI integration. Earlier we saw like a text to CAD, but as we are using various CAD application like a CATIA, NX and SolidWorks, there is an integration like many of you have used like a SolidWorks plus ANSYS plugin. So SolidWorks model is directly imported in the ANSYS easily without generating a step file and then import in the ANSYS. So right now, various AI integrations are available in market, which can be integrated to the CAD application easily. So again, it learns from the previous designs. So you need to generate a data for any AI or ML applications. Then it helps to optimize the geometry, and it predict the stresses, weight, performance, and within a time. You don't need to. Hello.
काढतो अजून आम्ही ते गळून नाही तर मी काढते तो मला होतो एक तारखे दोन
Okay. So you don't need to wait for the entire FERN to complete like a meshing one, or if it is a complex geometry. In my PhD time, almost 2 hours.
ट्राय पूर्ण समज
So in my research projects, almost 2 hours was for the meshing and then 2 hours for the simulations. So entire that 3 to 4 hours we can save. And AI become assistant inside a CAD. So it's not like AI will be the separate tool or what. It will be the plugin for your CAD applications. So there are several CAD plus AI features available, like Autodesk Fusion plus then SolidWorks plus AI based design assistance is there, Siemens NX is there, PTC Pro. There will be more. If you get some, you can also inform me. Actually, it is evolving now. So day by day, there will new things are coming. So next we'll move how SolidWorks or any CAD application and the AI integration is happening now. There is one tool called Make Agent. So you can search it on Google also, and on YouTube hardly 2 to 3 videos are available. So out of one, from that of one video, I have taken a screenshot and I am presenting because it's completely new in a market and not easily free. So it is Copilot for the designers. So even from the screen, you can see you need to give the prompt here and automatically it is get imported in the SolidWorks. So there was one example, the designing of the scooter. So here we wanted to make one fork. You can see the motor shaft and the wheel shaft. For joining this, we need a fork. So how to make it? So obviously, what I'll do, you will measure a center distance in the SolidWorks. Then you will apply your creative mind, design thinking. You will ask your friends or your teammates. कि हाँ बाबा कैसे बनाए इसको. So there will be the multiple options, but it will be time consuming. So in AI, you just need to give a prompt, generate a fork that connect the wheel to the scooter. And within a minute, it will give the available options. So obviously it's the options or results are depend on your fed data, like how much designs your projects you have done till date. So the AI work accordingly your past project. So it gives like these, and also it gives a option which kind of manufacturing do you need, casting or machining. Then which material do you need, steel, cast aluminum, and according to price, these prices weight is directly calculated from the density which is already fed in the SolidWorks. So prices it is picked from the market. Even sometimes it gives the reference of the site from which it is referred. So you just need to click here, add to CAD, automatically get added here. You can see. So it was a generator fork that connect the wheel. It was a prompt and it is a result. Then next stage was look for the suitable ball bearing online. So just click the shaft. It will automatically take the inputs like a shaft diameter 12 mm, and accordingly it will search for the ball bearing and it will give the online parts like a escape, shaft lever or an escape. In while bearing selection, we need to go to the escape side, then the product, then the needle bearing or ball bearing or any type of the bearing. Then we need to apply the filters like what is the ID, what is the OD, which kind of bearing do you need. It will be the tedious work. But here you can see it is directly given. Inside diameter 12, speed rating 60,000, price and escape type. Here you can see the link escape.com, ID, products and all. So it is easy to import anything. Then he done some changes in the wheel. So the find me a big scooter wheel with a 2 groove on it means it is already marked like earlier wheel was smooth. So added 2 wheels. Later he wanted to add some groove zigzag. So next prompt was like create a groove in the tire following the drawn space. Drawn space means you need to draw this zigzag pattern. Like we can add any zigzag pattern. AI will absorb that pattern, will create the groove accordingly. Means AI is very smarter nowadays. So next, within a minute, you will get this. You can see the preview, how it is acting. And after you can do the add to card and you will get the entire tire. So in Make Agent, the from that 4 to 5 slides, we generate the fork, then grooves on a wheel, selected the bearing. This is how we can do the various thing within a time without much more headache also. So Make Agent is new nowadays. You can go on a Make Agent site and I'll strongly recommend go on a YouTube and see the video. Because nowadays AI is evolving and the various new things are coming. So yeah, benefit will be obviously as I said, there will be the huge reduction in the design iteration time. And manual mode is very tedious. As we know, it's all depend on your expertise. The fresher will take a more time than expert person. And also in industry level, this difficulty happen when some experienced person left your company because that experience goes with him, and you don't have anything with you. So you just hire the new people and then again training. Instead of training the person, train the ML model that will be stay with you forever. So yeah, it is a data driven, which is a good actually, and traditional is designer dependent. In traditional, obviously slow iteration, and AI integrated will be the fast. So at we have seen the AI for the CAD. Only CAD means only for the 3D modeling and all. So next we'll see the how actual AI ML works for the design. So in CAD, it's mainly for the improving the model or making the drafting efficiency. And in CAD, it goes faster, automatic features recognition, then it reduces the modeling task, faster concept modeling. But in design, it is a purely engineering design decision making. It can predict your stresses, deformation, and for that we need to train a ML model from the previous data. Like you need to perform a 500 or 1000 FEA to learn the ML, and afterward you will get the results in seconds. Here we can do the multi-objective optimization also. So from the geometry-driven design to we are going towards the intelligent data-driven engineering. Even the geometry-driven design, that is AI in CAD is also good, huh? You can tell your student or you can apply in your daily life for generating various model if you don't have the SolidWorks. Everywhere SolidWorks is not possible. So you can just go on a online site and just make some model, even simple models that will work for initially. And nowadays students are very creative. So you even if you tell him such a concept is available, they will go and generate the data or generate the model also for the final year students also. So yeah, we'll move forward. So there is one question like, do companies really use ML in mechanical design? For MSME, way at very low, what we can say, low area, and MNCs are using nowadays because AI is coming. So like not everywhere and not for everything. So it is used where many iterations are required, means where more time is involved, tedious work, regular work. When your FA is very slow, like a gear, you are making a gear. Every time you need to make a gear, do the Lewis form factor calculations, then bending stress calculations, then selection of the width. So instead of that, directly you can learn. You can use a ML model, and after that just put the value, which model, which number, how much number of teeth, and you will get the desired results also. Okay, then in ALML we have the multiple variables, where the multiple variables are available for the optimizations. AIML is very good, and where price and cost, price and time is important. So how AI transform mechanical design? So it is automating the repetitive calculations. So you don't need to make every time एक ही calculation बार बार करना है. Just put the value, you will get the answers. So learning relationship between the parameters. Yeah, in manually we do the extrapolation, interpolation, but here it will work like various parameters, relationship between the parameters, like a P is directly proportional to T or n whatever 2 pi T by 60 and all. So this is how it works at back. It can predict the stresses, deformation, and or efficiency easily. Like a stresses in FEA, like I said earlier, we need to wait to finish the entire FEA. Many time your machine get failed and your half of the day is wasted. So the once you fed the data in ML model, it will be your base for your future. It will reduce the number of prototype. Like in my gearbox design, we made around 3 to 4 prototypes till final one. In industry, it is taking very big time for making the prototypes. For making one prototype, around 40 days, and designing time different. So around 6 months already passed. So you can use actually. It improves your design accuracy and real-time decision making within a time. You don't need to wait. So currently there are many companies, like I said, MNCs or bigger companies like BMW, Audi, and they are using it. And everyone is using for the optimization. Like I intentionally mark optimization red because every company nowadays, whether it is aerospace, automotive, manufacturing, everyone is going for the optimizations. Obviously for reducing the time and the cost, because company run on money and a company always looking for the highest ROI. And for that, you need to make a product with a lower cost. Yes. Then components. Not every component can be easily fed in the AI. The components like a symmetric and other simple components can easily, yeah, you can add complex component also, but not all. So bearings, frames, beams, gearbox assemblies, hydraulic component you can add for the AI-based optimizations. Again, as in previous slide, I highlighted optimization in red. Why optimization is needed? Obviously, to reduce the weight, increase the strength, lower the manufacturing cost, because in various industry there is one department only for the reducing the cost, or we have that department costing department also. It work on only to reduce the manufacturing cost, and design affects your manufacturing cost always, because various times we designers make your the model and drawing easily in a SolidWorks or any applications, but it is very difficult to make it on a machine. It saves development time also and improve the performance, enhance the quality. So what is the workflow for the AI-driven optimization? So normally we define the parameters. Like we wanted to make a optimization of shaft, we need to decide the shaft diameter, whether it is hollow shaft, ID, then OD. Then if it is a gear, we need to define the gear width and other parameters, material types of the components, whether it is EN24, EN1947, Maxomax, any other. Then we need to generate a samples design set, like what we need. One must stresses, strain, deformation, FOS, etc. or fatigue life cycle. If you go for the fatigue analysis, we get the life cycle of the component easily. Then we need to run these formula or FEA to compute the stress strain. And then after running the FEA, like a various models like a 500 to 1000 FEA you need to run. Then you need to put the data in an ML model. You need to train an ML model. Initially, this is time consuming, but this will help you in future. Every time you don't need to do the FEA, it will directly give you the value. Then you can use optimization algorithm. There is GA, that is the genetic algorithm is there, particle sort optimization is there, and then multi-objective evolutionary algorithm is there. So you can search for this algorithm also for the deep study, and after that algorithm you will get the best result, and you can validate this result through the CA or prototype. You can't 100% rely on the AI or FEA also, huh? because I have seen the actual cases where the FEA shows the product is safe, but in shop floor it's get failed due to the various conditions. So even it is AI or ML giving you the results in a 10 or 20 seconds, you need to validate it. So we'll move to sorry. We'll move to the various AI methods or AIML methods used in the design. But it is not only design, for the every sector it is applicable. So first is like a machine learning regression. So it can predict the stresses, deformations or strain from the your data only. You need to train AML and you will get it. And then classification algorithms. Classification algorithm will tell you like whether your component or your design is safe or unsafe. You just need to give the condition like your stresses should not be greater than 100 MPa. If whatever is above the 100 will be go in the unsafe area, and below the 100 will be in safe area. So then genetic algorithm. So it will be for the optimization of weight or maximum for the maximum strength. It will be the selection, mutation, and crossover. Various things like a GA, artificial neural network. It was in MTech also, MTech syllabus also for the productions. Obviously in theory. Then neural networks, surrogate models replacing expensive FEA. Here it will again it will predict the FEA result from the past data. In neural network will work like your that is a human mind. Then topological optimizations. I strongly believe many of you must be knowing the topology optimization word. Like in earlier one, we have seen the parametric optimizations for my research project, but there is one term called topology optimization. It removes the unwanted material. We'll see the topology optimization example in deep. Then reinforcement learning. It's like a learning from the environment. It's kind of closed loop system. You get the feedback from the environment, then you change again input, and then you try until you get the result. So we'll go one by one. It's this part is quite theory, so you can just see what are the terms, and for the deep you can just go and search for the deep knowledge also. So in machine learning, it is predicting the numeric values based on your inputs. Like I earlier said, we need to train a ML model, and for that you need to perform hundreds of simulation. Like I am talking about simulation because we are talking about the design. In design there is FEA, so it can easily predict the stress, deformation, and fatigue life, and it can replace the repeated FEA simulations. And repeatedly saying that various AI/ML tools can be used to replace the FEA simulations. It can replace the FEA simulation at a later stage, not at a initial stage. Initially, you need to perform the FEA for the 1000 model. Again, I will repeat the same word. You have to train a ML model. Otherwise, it will not get the data, and entire AI/ML is data driven. So it's enable the fast design optimization. So it is like I said in earlier slide. So this is how the workflow: design variable, then FEA simulations. From that, we'll get the stress and deformation data set. For the X input, we will get the Y output. You need to use will use this data set for the training the ML model, then ML regression model, then optimizations. That is prediction. Like, yeah, if we wanted to make a cantilever bracket optimization, we'll select the thickness, load, Young modulus, then output will be the maximum master stresses. Like it must be less than the Young modulus, otherwise your product will be failed. So step-by-step process, FEA data set. Again, you need to run hundreds of simulations. by varying a thickness, load, and this you need to export these stresses and deformation, make data set table. Then you need to train AIML regression training. And later for the new design, like I have done 500 simulations for my cantilever bracket, which is my regular product. Like a various company, you can go and see they are making only one product. As I'm in the Bhosri MIDC area, one company is working on the one product of Tata Motors or one product of Mahindra. Regularly, 1,000 lakhs of products they are making. So for one that product, they can actually use this model. So for that, if you train the ML model like that, you will get the new design easily. If you wanted to change the thickness, if you wanted to change the load, no FA will be required in later stage. Then we can go for the there is another type called reinforcement learning. So in reinforcement learning, it learn with interacting with the environment. It's kind of you can say the human get the feedback from the environment, then it add the feedback, it gets rewards and penalties. If your value is towards your objective, you will get positive rewards. If your value is away from your objective, then it's penalty. Yeah, it is learned by trial and error. Then the goal is always maximizing the cumulative rewards. Cumulative rewards maximizes means we have to go towards our objective. So this is just AI generated one image. So a kind of agent that take feedback from the environment, it will get reward or penalty according to the objective. I have one example for this, and then this system will follow the closed loop system and then accordingly update the strategy. Yeah. So in my products, like a battery torque range using RL, we can say the agent is torque controller. You can see here the gun. It's kind of drill machine. You can easily see here where tri-torque sticker is attached. It is a gearbox and it is an output shaft, which is run at the desired RPM. Here you can adjust the torque value, and inside the gun there is torque controller. What it controls? It controls the torque value by adjusting the speed, angle, or current. Actually, as I said, one formula early, the power is equal to 2.0 by 60. So from the battery, there will be the 18 volt continuously, 5.2 amperes rating. So accordingly, it will absorb the power, and controller will decide how much power must be supplied for the desired torque value. So initially, what will be the reward? The reward will be the accurate torque and low overshoot. Means your accuracy must be within a range like plus minus 5 or plus minus 3, whatever your desired result. Then if you get, you will get reward low if your torque is over torque or there is a low torque or delay or error. So result is like it's improve your torque accuracy. Here, as we are making a 4 different models on a one controller. In one controller, we have already invested like a 3 to 4 months and various time plus money also. Okay, but for next model, we have already trained. Now it is not ML model is trained. Now persons are trained, and we have data how the torque and your current is correlated. Like our motor, like our output is around 300 Newton meter. Suppose it required 2500 MV from the controller, and for the 1400 it required 4000 millivolt. Accordingly, we have already calculated the various value of the current, and it is actually we are doing it. And for the another model, it will be taking less time, as we already know how it is happening, everything, like how controller is adjusting the current. So advantages like works well for the control and optimization, handle complex systems, no need of predefined model. Here we didn't had any controller with us, so we work on it and we got the results actually. And again, for every model, whether it is MLR or RL or GA, the one disadvantage is always there, one limitation is always there. It is computationally expensive. You need great computational power. When I was in my PhD, there was a towers in entire towers means computer towers in entire lab for the running the CFD, running the Python and FE and all. So it requires the expensive computational power. Then require large training time. Yes, you need to train your ML model and very accurately. If you are training your model in a wrong way, your results will be wrong. Then neural networks. Neural networks are like a human brain. There will be the various neurons we are connected, and there are input layers, hidden layers, output layers. So inputs layer you will receive a data. Hidden layer will perform some computations, whatever they are objective, and then you will get the output. Then we can also give the weightage for your inputs. Then we can add the bias and the activation first functions. So this is some one schematic for the neural network. You can see here the how all the nodes are connected. It's like our brain, various elements are connected, kind of, not exactly. So again, I have taken a torque prediction example. So inputs were the motor current, voltage, speed. Output was the predicted torque. So here accuracy, how to get the accurate value and how to validate it, main question. You can get the torque estimation without a physical sensor, because we need to validate your output. We have our own calibration, but after the programming in the controller or whatever we are changing in the controller, we validate it on our calibration. So useful for control and calibration is right, but in every model, whether it is ML or AI or FEA, you need to validate. Even in our battery talk range, we are validating our controller with using a calibration, whether our calculations are right or wrong. Many times your calculation gets wrong or get error. There are many other factors affecting your products, whether it is environmental or others also. Then in ANN, advantages are like they can handle non-linear and complex systems, high accuracy, reduce need of manual engineering, and can be scalable to large problem. Again, here you can see the limitations in every slide. You can see the limitations, same, computationally expensive, require large data set, etc. So topology optimization, it will be quite engaging. It will be engaging because you will see the red and blue legend of the FEA. And topology is, I strongly believe everyone has already heard about it. So topology is for the best material distribution, or it will remove the material where it is not needed. So the where is material really needed and where can it be removed. So these all images are generated using AI, means using ChatGPT. Means for the making the presentation on AI, I have used the AI to generate the images and data also. So you can see the use of AI now. So and again, our prompt must be right. So let's consider one cantilever structure is there. We need to make a optimized structure using a topological optimization. In topological optimization, there is always initial product, and there is one term called generative design where there is no need of initial model. It will automatically make a product or make a component. In topology, we need to give the basic inputs like what is the design space, then what is the load, what are the constraint, what are the material, and what is the objective. Like you can add the cantilever load here, but you must know the objective like a minimum weight. Then you need to have a FOS around 2. And depending on your application, your FOS will be changed. We normally have the 1.5 to 2 FOS at our tools. So torque arm or bracket optimization, you can see initial design is this. You can get like this, like you can fix here. There are various mistakes in the AI generated images also. So you can see the material can be removed where it is not needed, and where you can see the red one, that is a higher stress, there is more material, and where is blue means lower stress, we can have the lesser material. Also, you need to give the constraint like what is your member thickness. You can go below your desired value. You need to give some values like yeah, I need a 5 mm thickness. Then what is the minimizing the compliance or maximizing the stiffness? Then it will obviously remove the material. It's not 60% exact, but it will obviously reduce the material. So here just these images are for representation only, not exact values. So if your product was like a 2.5 kg earlier, and after optimization you will get 1 kg. So weight reduction you will get around 60. Even along the weight reduction, you also get the stresses will be increased. But earlier FOS was 2.5, now it is 1.5, and you need only 1.9, and you need like a 1.5 FOS minimum. Still it is safe. So you can go for these value. Then in topology, you can't directly use your model, because in topology the material is removed in a crude way, it is not smooth way. So you need to make every profile correctly. So you need to add fillet, uniform thickness, and then you need to also revalidate with the FES. Means after topology you get one optimized model, you need to run FEA one or twice, and then you can see whether it is possible to have the manufacturing easily. Then we'll move towards the genetic algorithm. So genetic algorithm will work on the principle of the survival of fittings, and it will be for the optimizations, and it will inspire with the natural evolution. Like you say, like our grandpa and then our fathers and we and our children's. Nowadays, Gen Z is very active or very creative, but it is not discipline, huh? Even if you hire some Gen Z, but Gen Z mind is working very differently than our mind. So it is evolutionary. So I have taken a spur gear optimization using genetic algorithm. So in spur gear, we need to give a data like a model is 2 mm, number of teeth are 17, tangential load acting on a teeth is around 100 Newton. And everyone know the formula MB sigma BY is equal to force from our data book or VB Vandar, you can refer it. Then allowable bending stress is around 100 MPa. Then what we need, which variable can be changed, like a width. Here, if your load is constant, why is constant? Because your M and Z is constant. M is already constant. Only varying is your B, because your material is also constant. So your face width will affect the gears, whether it is safe or not. Then chromosome is your B, that is width. And accordingly, our fitness value is 1 by B. What is 1 by B? We need to maximize the 1 by B. That is the minimizes the B. We can't take randomly any width because it is safe. Means we can't make it over design. So how genetic algorithm works, like it do for the various iterations. The candidate was B, that is a width, and it is changing. Here you can say safe, unsafe, safe, unsafe. It is a classical classification algorithm. It comes under classification algorithm, but you can see the last one. It find optimization. That is GA. GA is normally find optimized value. So you can take actually 16.8. We normally works with the decimal values also. But for the whole number, you can go for the 17, and you can in tolerances, you can add minus 0.1, minus 0.2. That will work actually. So genetic algorithm gives the optimized value. So in entire presentation, you might see I have taken only the two examples, like a gear, because it was my running problem. I was working on the gear and I work on it with the AI models and other tools also. So GA approach is always automated global optimizations. Again, few advantages like a handle discrete and continuous variables, easily scalable, suitable for complex mechanical systems, and again limitations like a computationally expensive and need proper tuning, which population size must be given, and quite slower than other gradient methods. And also, I repeatedly saying validation with the FE is required. You can't directly select the gear just because any AI model is given you. So, yet we have covered like a theory and just few example. I hope everybody is understood very well. Then, yet what is my observation across the industries? Industry is adopting AIML very slowly. Even we have a team of 12, we are not using it at a higher level. Nowadays, everybody is using a ChatGPT. Even for the generating image, you can see the background images. That is a gear with this light flashing on it is generated in ChatGPT, or you can use a Gemini. But in design wise, it is adopting very slowly, just because they don't have the skilled engineers who know the ML. When we don't, even if you are talking to me, I'm not expert in ML. Yeah, I can say I'm expert in design. Yes, but we need to think in that way how we can use the ML in a broader way for our design. Okay. Then quality of data sets is often low. As we are training up ML model, we need a high quality data. Nowadays, designers who are really working on ML need a time to learn that. Also, in research, it took around 4 to 5 years to work on the research projects. Like we had 2 to 3 guys were working on the ML in our lab. So then need for the verification. Like AI must be validated with the FEA. You directly can't trust the AI models. You need to validate with something, whether it is physical or FEA. And then cultural hesitation. Yes, engineer trust one form. Engineers always go for the formula base. Even today, we have the Mahadevan data book. We go to Mahadevan data book, then VB Bhandari and others value. Even we don't trust the chat GPT ka formula many times because it gets some wrong values. So these are the reasons, but yes, many companies are adopting. And being a teachers, we all need to train our students so they can use ML in their industries. So in entire presentation, you must heard from me that we need to perform the hundreds of FEA models, though it will take time, but afterward, FE is not needed. Currently, we need to invest time in FE and database, but later, even after 1 quarter, your designer left your company and you hired one fresher. He can just give the prompt, and within a moment, you will get the values. It also makes design optimization very fast. because in traditional way, it's all depend on your expertise. What is your expertise? How's your designer how your designer is expert, how your manager is expert, depending on that you take the decision. But AI, it will get very fast. Then it enhances the optimization capability easily. It allows the real-time stresses and prediction inside the CAD. Like a real-time means what? You don't need to wait for the hours to complete the FEA and all. You just put the value. Key, my gear width is 17 mm. What will be the stresses? It will predict the stresses. It will predict the stresses, not will run the FEA. Huh? Okay. Then one model serves as the entire product family. Yes. If you give the good database to train the ML model, it will be served as a reference. And then single AI model is reusable across the entire team. So like I said, if I made the ML model, then every designer, every teammate can use it. Even I have example for this. Then you can see there are 6 methods we have gone through, like a ML regression. It's predict the stresses. Then classification. Classification model will tell you only the whether it is safe or unsafe. Genetic algorithm will work for the optimizations. Neural network is work on the surrogate model. That is it predict the FEA. It predict the FEA depending on how you trained your ML model. Topology, obviously, weight reduction. You will get the lightweight body. And reinforcement learning, it is a deep autonomous design. It's work on the how you get the feedback from the environment. So this was the summary of the 6 types. The future, obviously, as we are talking about the AI ML, the future is already started. As I have shown you the CAD plus AI integration model. They're started, not expert in that domain, but like a make agent is trying nowadays to get expert in CAD plus AI integration. You can just for the curiosity, I'll suggest everyone to go on that site, whether it is Zoo or CAD Scribe, and share your experience. Actually, you can share me the experience on LinkedIn also, whether you really feel that Zoo or Leo AI is useful. Then automated design assistant are available. Then generative design for the metal composite. Generative design means without giving the any reference model, you will get the designs. And in future, obviously, it will be the standard. Like nowadays, earlier we had in 2010 in my engineering we had AutoCAD. Sabka AutoCAD आना चाहिए. Nowadays, nobody is using AutoCAD in product design industry. In product design industry, yeah. I'm not talking about the others. So then we move towards the SolidWorks. Then SolidWorks, then FEA. For FEA, then Nancy is hypermesh for only for meshing. Then now it is AI. So yes, we need to change according to the what we can say generation. And obviously in next 5 to 10 years there will be the AI will be the standard in everyone. Means अभी हम लोग इंटरव्यू में पूछते हैं, do you know to use SolidWorks or NX? In next 5 to 10 years we'll ask him the what is the ML model, how to run ML model, do you know the coding behind it? Means mechanical engineer must know everything. Yes, future of CAD plus AI, yes. Fully autonomous part modeling will be there. Automatic drawings generation. Even from the drawing, as you know, earlier days we used to draw by hand, then AutoCAD, you need to create all 3 models. But in SolidWorks, you don't. You just pick the 3D model, you will get all the models easily. Then voice control design and many more. Time in running, I'll just skip this part. Yeah, I need to give you example how AI ML I have used in my research project. So earlier I said the receiver plays an important role because every solar radiation incident on the mirror strip is reflected back to the receiver. So the we we were wanted to know the exact position for the perfect efficiency or optimized efficiency. So in crude way, what you have done, we put the PVC strip at the different distance, and what we found, the strip near to 1.6 to 1.61 mm got burned in a second. The temperature was here the 238 degree actual temperature. Huh? So later our guide Professor Dalvi made AIML model for this. So for that, we use SolidWorks, Excel, and Python. From the coordinates of the parabolic trough are generated from the SolidWorks, then imported in Excel. That Excel is linked to the Python. You just need to change the number of rays in a Python. It will automatically get reflected here. For Python, we have used the Anaconda, and you can see the rays actually here, the bigger picture. You can also adjust the number of rays. Here you can see the rays are not all rays are incident on the circular pipe. Some are at the cover. So you can the predict the efficiency easily. What is the loss? And there is always deformation. For that, we have taken offset. When there is a deformation of 15 mm, the more rays are colliding with the outer surface of the receiver. So accordingly, we have done the analysis, and there was again we used ray tracing for modified compound parabolic collector. We made two models, parabolic trough collector and compound parabolic trough collector. In that, modification have been done, and then you can see for the all the rays are colliding or incident on the receiver. Here you can see all rays are incident on the receiver. But when there is inclination in the structure, what will happen? So you can see we just change the angle of rays, whether all the rays are incident on the receiver. We check here. You can see if we change the inclination, you don't need to change the entire coordinates. You just need to change the angle in the Excel file. Within a minute, you get the results. So I was an end user of this ML model, not a creator. My professor was a creator. So we use actually one model was used in the entire solar group. Like I said, the advantages of ML, once it is made now, it is used by entire family or entire designer. Currently, the current team, solar team is different. There are different students, they are using it just like this. Within a minute, we get the results. And accordingly, we do the optimization and we find out the mirror strip width, because our entire project was based on the strip based system, not a parabolic mirror. And our professor had already had the pattern of this for the mirror strip based parabolic trough collectors. So this is how we use ML model in our research. So summary, we can say AIML is really faster and smarter for our design. So we need to do some analysis and generated data. Okay, and it can do the thousands of combination of design easily, enabling the effective optimizations. And it can save the various time, several time, like you need to invest initially. Like in business, we say capital investment karo, baad mein profit hai, waise kind of. The AI supports the engineers in decision making, but not replacing the engineers. Huh? For that, we need engineers, because we need to give the prompt, we need to train a model. For that, you need intelligent engineers also. Then accuracy will get higher if your data set is great, and the extrapolation is risky. And I have tried one extrapolation method for gears. It was giving some wrong error also. Best performance is achieved by integrating CAD, CAE, and AI ML together. So the final outcome is like CAD plus AI is equal to faster, smarter, and more reliable design. So So again, thank you so much for listening me and bearing me for 1.5 hour. So if you have any questions, please let me know.
Yeah. Participants, if you have questions, you can ask. Let me check muting.
Hello. Hello, sir. Hello, Pradeep,
Sir,
sir.
excellent session, sir. Excellent session. Actually, I would like to thanks to you. The session is very excellent. No, I have not unmute myself for any question, but the section is very good. I really like it. But one more thing is, I'm continuously demanding for this material. If it is
Okay.
possible for everybody to
Yes,
share
yes.
material, so
I
it is
will I
very
will
informative.
share with the Shelar sir, and Shelar sir can share with you.
Please, sir, please. It's
Yeah.
today's session is very informative and very helpful to everybody for all the institutes. Thank
Okay,
you so
okay.
much.
Thank
Thank
you
you
so
so
much,
much.
sir. Thank you so much.
Hello, Pradeep, sir. This is Arungatin speaking from CV University. Am I audible to you, sir?
Yes, sir. Yes, sir.
Sir, actually, it was a wonderful presentation, sir. I think nearly I have attended 5 to 6 FTPs
Okay.
relevant to AI and mechanical applications. So I think you are only one discussed about AI plus CAD. I mean AI plus design and analysis. It was an excellent
Okay.
session, sir. I really enjoyed. I think at the
Okay, sir.
beginning you have asked, "Are you enjoying?" Like, really, we enjoyed, sir. Actually. Fine, sir. And a few things I want to discuss with you, sir. It's actually so many complications are there in design and analysis because
Yes.
the analysis based on, I mean, the design is we have different designs. Like, I mean, you have made a simple design. If it is going to complex or multi contour components, is very difficult to design as well as I mean machine. So yeah, if the same material with discretization of elements, same for analyzing, we are going to discrete. It means we are going to make a mesh.
Mesh, yes.
Yes, if you are increasing the mesh element size, so that also plays the important role in FE analysis. Actually,
Yes,
we are not
exactly.
getting the same results in repetitive analysis.
Yes, you need to have the FA itself has a rule that more the number of elements you will get the higher accuracy, but it will increase your time or computational time.
Yes, correct, sir. So I'm excited to see wonders of AI in CAD and analysis, sir. I think you are already started working on it. So actually, I followed your LinkedIn, sir. I think uh, looking for more advancement in AI plus CAD and analysis. Sir. Thank you so much for a wonderful session, sir. So yeah, this is new to me. Really,
Yeah.
after Corona, everyone is talking about AI plus some other applications, data driven, data mining, something. But it is relevant
Yes.
to mechanical, AI plus mechanical, AI plus, I mean, design analysis. So very excellent, sir. Really enjoyed. It's a worth attending. Thank you.
Thank you so much, sir. Thank you so much. It's my pleasure, sir.
Sir, possible, if possible, share your contact number, sir, please.
Yeah, yeah, sure. You can just should I share here on chat? Chat is very chat. You can just
Put
ping me on
put a
LinkedIn.
message, sir.
Okay,
Message,
okay.
chat message.
348 Yeah, I shared.
Thank you, sir.
You can WhatsApp me, no issue, or you
Yes,
can call me. But
yes,
you can contact me on LinkedIn also. I'm regularly active on LinkedIn for the various articles and all.
yes, sir. Yes. Thank you.
Thank you so much. If you have any suggestion for the improvement, I'll just you can share with me and I can just implement anyone, no issue. Because
Yes.
because my motto was to give you someone nice insight. Even while making this presentation, I learned many things. Like from since 1 month, I was working on the presentation. So it was giving a 1 hour lectures. Mean you need to have a, bigger data set to explain. So even I learned many things. I really thanks Shelar sir for giving me the opportunity and Zeal Institute and you all for listening me carefully.
Actually, we have to do it reverse.
Hello.
We have to do it reverse. We should thank you.
No, sir. It's my pleasure, sir.
Any other participant question?
Yes, sir. Sir, am I audible?
Yes, sir.
Yes, sir. That was a nice interaction between the integration of CAD and FEM, clubbing AI into it. So I have a question regarding this, the genetic algorithm, which is non-gradient optimization technique used to explore the machine design applications. So are you worked on only kind of development or kind of any research over it?
No, in ML, I have not done on a back end, like I said, not in coding and all.
Not ML, sir. The optimization technique, the one which you have used, genetic algorithm, which is a meta-heuristic algorithm, non-gradient based optimization technique. It's not machine learning, by the way.
No,
So
no.
the one
In GA, I have not gone in deeply.
yes,
Yeah.
means you have shown one per gear application.
Yes. It was only for the showing here because it was not. I had only 1 month, so going deep for the every. But I have done in topology and other applications like a parametric in deeply, not in GA. Sorry.
Okay. So coming to topology optimization, like
Mm-hmm.
design the structure, keeping the constraints as a target, like kind of either minimizing the compliance or maximizing the stiffness, keeping the volume as a constraint. Is that what we looked into, sir?
In topology, like I shown you my receiver support. Like a receiver support is going to have the uh, cantilever structure. You need to fix here only, and you need to put force here. And many time what happen here, you don't get stresses. So it's in topology actually it's remove that area in a very crude way. You need to give the load, and in load you can vary your range, and you need to give constant like in parametric. Also, you have like a thickness must be 5 to 6 mm or whatever the range. It will remove the area, then that area will be removed in the crude way. You will find it is not in a line. It will within the any random area. The blue portion will be gone forever. So you need to work on that model. Like in ANSYS, it is topology optimization is available. You can go, and after that you need to again work on that 3D model and again FEA.
Okay, like you use the inbuilt models available in ANSYS. It's not
Yes,
like
yes, yes,
developing a
yes.
code by
No,
yourself.
no,
Like
no, 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 not code. Even for my research, I have used code developed by my professor, not by me actually. So we were used
what is the
to
code, sir? What is the kind of algorithm you use it for topology optimization?
where
As for what is the kind of algorithm you use it for topology optimization? Like in the literature, we will be having one is the topology optimization proposed by Ole Sigmund. He proposed using optimal criteria method, and there is one more algorithm MMA proposed by German research community, I guess, and there is one method proposed by I think Chinese level set method. These are the basic core structure of algorithms used for structural topology optimization, and
okay,
these algorithms have been inbuilt in ANSYS as well. The
okay.
ANSYS picked up these algorithms from the research community. So I just wondering like what your professor have used or implemented their own codes. Just I'm exploring for the
Okay. Yes,
research part.
I'm writing it down. So these are the new for me. So I can
Oh,
just contact my professor also because we are in touch today also. So no issue. It will be the inputs for me also.
Okay. Okay. Thank you, sir.
Yeah, thank you so much, sir.
Participant, any other question? Okay. There seems to be no question right now. Dr. Puneet, thank you. On behalf of Zeal College of Engineering and Research, Pune, Mechanical Engineering Department, thanks for your support for conducting this session. You have been being support for last 6 months. The day we planned this event session, we are constantly updating yourself, and it will help us to update our community, mechanical engineering community as such, that just by texting we can generate products, and especially we also can design the products. It's a quite
Yes.
difficult task. Your valuable insights will definitely help our mechanical engineering community. Thank you, sir.
Thank you so much, sir. Thank you, guys.
Yes. Stop.